Welcome back to Daily Dose of Space. Today, we're looking at an unusually active moment in our corner of the universe. In just the past few days, we've seen an interstellar comet become visible again from Earth. A rare long-period comet appear over the Middle East. A solar storm physically tear apart a comet's tail. And NASA hit a major milestone: 6,000 confirmed exoplanets. And if that wasn't enough, new observations from the James Webb Space Telescope suggest the presence of a planet orbiting the closest known solar twin to our Sun. It's one of those weeks when the sky feels very much alive. So let's take a look at what's happening. 3I Atlas becomes visible again. Let's start with the object that has been generating attention since the moment it was discovered: 3I Atlas. Only the third confirmed interstellar comet ever detected. After months of tracking, new observational reports confirm that the comet is once again visible from Earth through small and medium-sized telescopes. This is noteworthy because 3I Atlas is not bound to the Sun. It's passing through our solar system at high speed, following a hyperbolic trajectory that indicates it originated from interstellar space. Being able to see it again means astronomers have another opportunity to collect data on its brightness, dust activity, and trajectory before it leaves for good. Researchers are hoping to refine estimates of its size and composition. Interstellar objects do not behave exactly like solar system comets. Their surfaces may have been exposed to cosmic radiation for millions or billions of years without the protection of a parent star. That exposure can change the chemistry of their outer layers, making them appear darker or less active than expected. Every new observation gives scientists a clearer sense of whether 3I Atlas resembles Oumuamua, the extremely unusual first interstellar object ever detected, or Borisov, a more conventional comet. For now, it looks like 3I Atlas falls somewhere in between, faint but active enough to be studied before it disappears back into deep space. A rare long-period comet, CU 2025 R2 SWAN. Next, in the skies over Oman, astronomers recently observed a rare long-period comet named C 2025 R2 SWAN, returning to the inner solar system after an estimated 20,000 years. Comets like SWAN originate in the Oort cloud, the distant icy sphere that surrounds our solar system at nearly a light-year in radius. The discovery helps scientists understand the populations of Oort cloud objects and the long timescales on which they migrate inward. Large comets like SWAN can reveal clues about the early solar system because they have remained largely untouched since their formation. Unlike short-period comets, which repeatedly swing past the Sun and lose material each time, long-period comets retain pristine, ancient ices. The Oman observation campaign is important because it provides early tracking data. Knowing SWAN's brightness and trajectory now helps scientists predict how active it will become as it approaches perihelion. If its surface contains volatile ices, like carbon monoxide or methane, activity could increase dramatically. For now, it stands as another example of how quiet cosmic visitors can suddenly appear after tens of thousands of years in darkness. Solar storm tornado, the Comet Lemmon event. At the same time, a strong solar storm recently passed through a region of space containing comet C 2025 A6 Lemmon, and the interaction temporarily tore off a large portion of its tail. This is not unheard of, but it is rare enough that it attracted significant scientific interest. A comet's tail is formed when solar radiation and the solar wind push dust and gas away from the nucleus. Under normal conditions, the tail stretches away from the Sun in a smooth, predictable direction. But during a geomagnetic storm, the solar wind becomes turbulent and energetic. In this case, the storm carried enough force to detach part of Lemmon's tail, creating a momentary break. Events like this help researchers understand how comets respond to extreme conditions near the Sun. The tail will naturally reform, but the disruption provides a glimpse into the balance of forces shaping cometary structures. It's a reminder that comets are delicate, constantly shifting objects, and that the Sun remains far more dynamic than most people realize. NASA reaches 6,000 confirmed exoplanets. Meanwhile, NASA has reached an important milestone: 6,000 confirmed exoplanets beyond our solar system. This number represents planets verified through multiple detection methods, including transit observations, radial velocity measurements, direct imaging, and microlensing. The diversity of these planets continues to grow. Many fall into categories that don't exist in our solar system, such as hot Jupiters, super-Earths, sub-Neptunes, and lava worlds. Others orbit extremely close to their host stars, completing a full year in a matter of hours. The milestone is a reminder of how quickly exoplanet science has advanced. Before 1995, no exoplanet had ever been confirmed. Today, astronomers are detecting new planets almost weekly, and future missions, like the Habitable Worlds Observatory, will focus on atmospheric signatures, including potential biosignatures. Every new planet increases our understanding of how common worlds like Earth might be and how many potential environments for life exist throughout the galaxy. A potential planet around a solar twin. Finally, new observations from the James Webb Space Telescope may have identified a planet orbiting the closest known solar twin, a star extraordinarily similar to our Sun in size, temperature, and composition. Solar twins are valuable targets for exoplanet research. If a solar twin has planets, it gives us insights into how typical or unusual our own planetary system might be. Webb's detection, based on precise infrared data, suggests a possible planet whose presence is inferred from subtle variations in the star's light. If confirmed, it would mark an important discovery: a planetary system that could closely resemble our own in its earliest stages. The data also helps refine models of star and planet formation, especially around Sun-like stars. More observations are expected, and astronomers are optimistic that this system will become a high-priority target for future telescopes. From interstellar comets and ancient cosmic visitors to a growing census of exoplanets and the discovery of worlds around stars like our own, this week highlights just how dynamic the universe is. Objects arrive from the deep, comet tails stretch and snap, solar storms ripple through space, and new worlds continue to emerge from the noise of astronomical data. Even on quiet days, the universe is changing. But weeks like this remind us that we're watching just a small part of a much larger, constantly moving picture. Thanks for watching Daily Dose of Space. If new updates on 3I, Atlas, or the solar twin system appear, we'll cover them here.